An unsettling discovery approximately this massive celestial body, renowned astrophysicist Brian Cox has issued a grave warning leading to the looming query. Are we approximately to witness a catastrophic supernova explosion that should completely modify the night sky? Hermits delve into this phenomenon inside the sizable tapestry of the cosmos where stars are born, live out their lives, and in the end die in magnificent displays. One star has lately captured the interest and concern of astronomers and the general public alike. This star is Betelgeuse, a crimson fantastic large of immense size and age prominently located within the constellation Orion. Its wonderful reddish hue and variable brightness have lengthy interested observers, but recent trends have intensified interest on this celestial massive. As we discover Betelgeuse's nature, we find ourselves on the threshold of a probably monumental occasion in its lifestyle cycle. However, what do these adjustments in Betelgeuse mean? Could we be witnessing the prelude to a cosmic spectacle of unimaginable importance? Betelgeuse, approximately 764 times larger than our Sun, is a stellar massive. Its giant size is nearly beyond human comprehension. Consider a star so full-sized that if it had been to replace our Sun, its surface could extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This large length isn't always just a testimony to Betelgeuse's bodily attributes, but also signifies its degree inside the stellar life cycle. As a red fantastic massive, Betelgeuse is inside the twilight of its existence, a phase characterized by expansion and cooling after a life spent fusing hydrogen into helium in its center. However, how antique is Betelgeuse? This superstar, believed to be around 8 to 8.5 million years antique, is rather younger in human terms but historical inside the context of stellar lifetimes. Its present pink fantastic giant section is the fruits of hundreds of thousands of years of stellar evolution marked via dramatic modifications and techniques that have transformed it from a hot blue superstar to the purple giant we see these days. The life cycle of stars like Betelgeuse is a tale of transformation driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's one-of-a-kind hue is another hallmark of its current degree. The pink color consequences from its distinctly cooler surface temperature compared to stars like our Sun. While the solar's floor temperature is about 5,500 K, Betelgeuse's cooler surface registers temperatures around 3,500 Kelvin, allowing it to emit mild at wavelengths that supply it a purple look. However, this coloration isn't just a visual trait. It gives insights into the celeb's physical circumstance and the procedures happening inside its significant gaseous expanse. Adding to Betelgeuse's mystique is its historical shade trade. Historical Roman and Chinese language records suggest that around 2,000 years ago, Betelgeuse appeared yellow. It was best in the 99th century that Arabic pupils first described it as crimson. This coloration shift over human history isn't only a component within the annals of astronomy, but also a clue to the celebrity's evolutionary route. The variable brightness of Betelgeuse is every other intriguing aspect. It is a semi-variable superstar, meaning its light periodic waxes and wanes, a function dance of luminosity that has involved astronomers and skywatchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle, along with a longer cycle that stretches about 5 years. These cycles have been documented as far back as the 36th century by using Sir John Herschel and probably even earlier in Aboriginal oral traditions. What makes Betelgeuse virtually enigmatic isn't just its converting brightness but also its irregularity. Unlike many stars that follow a predictable sample, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood strategies happening within its giant form. In a latest groundbreaking revelation, Betelgeuse captured the attention of astronomers and stargazers worldwide with an unexpected and dramatic trade in its appearance, now famously known as the fantastic dimming. In past due 2019, Betelgeuse, the crimson tremendous large and one of the brightest stars in the night sky, placed prominently in the Orion constellation, started to dim mysteriously. This dimming became so extremely good that it began losing its brightness at an average price of 0.1 magnitudes per day, achieving its lowest factor in February 2020. Betelgeuse, normally visible to the naked eye even in regions with light pollution, became extraordinarily fainter, a trade that amateur observers may want to easily spot. However, monitoring Betelgeuse's activities poses a challenge due to the time paradox. When we take a look at a superstar like Betelgeuse, we're seeing it not because it exists inside the present, but because it was in the past. Because of the time it takes for light to travel to us, in the case of Betelgeuse, which is about 725 light-years away, the light we see nowadays left the celebrity almost 7 centuries in the past. This time lag makes predicting and monitoring surprising modifications in a celeb's behavior tough, as we're essentially searching into its past. The dimming occasion of Betelgeuse highlighted the inherent problems in real-time astronomical observations and the limitations of our information while managing the vast cosmic scales and the time paradox they brought. This celestial drama of Betelgeuse changed into carefully determined by Andrea Dupree, accomplished director of the Middle for Astrophysics at Harvard and Smithsonian, and her crew. They used the Hubble Area Telescope to take a look at the giant celebrity as a part of a 3-year study on variations in its outer atmosphere. These observations provided a unique perception into the dynamics of a variable superstar like Betelgeuse, which expands and contracts, causing fluctuations in brightness. By analyzing Hubble spectra, the researchers measured the motion of cloth in Betelgeuse's outer environment, particularly that specialize in magnesium-2 traces, which suggest the star's atmospheric situations. These observations found out fabric shifting at speeds of approximately 200,000 miles per hour from the star's surface into its outer environment. This warm, dense material subsequently prolonged hundreds of thousands of miles from Betelgeuse and became the precursor to the dirt cloud that brought about the celeb's dimming. Dupree and her team predicted that approximately 2 times the ordinary amount of fabric from Betelgeuse's southern hemisphere was misplaced over the 3 months of the outburst. This mass loss changed into huge, specifically considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate some distance more than that of our Sun. The size of this mass ejection and the following dimming sparked discussions among astronomers about whether or not this event might be a precursor to a supernova explosion. Betelgeuse's proximity, approximately 725 million years from Earth, adds to the anticipation as this type of explosion would be seen from Earth and provide a rare possibility to study a supernova up close. But the query remains, what does this dimming occasion mean for Betelgeuse's future? Is it a signal of an approaching supernova or sincerely a unique episode within the star's lengthy and complicated life? Several theories were proposed to give an explanation for this surprising alternate. One common concept suggested a phase within the supernova explosion procedure, gaining traction because of the common notion that Betelgeuse is nearing the stop of its life. Another popular theory implicated dust, probably from the celeb itself, obscuring our view. Betelgeuse, like other red fantastic giants, is thought to shed material, and this cloth could form a dense enough dust cloud to dim the celeb's light from our perspective. A third clarification considered adjustments in the CB's photosphere, the visible floor layer that can affect its apparent brightness. In-depth analysis using numerous observational strategies helped resolve this mystery. Spectroscopic studies indicated a drop in B's effective temperature, suggesting that the dimming may be due to a large dark spot on the star's surface. This theory becomes supported by the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, indicating vast modifications on its surface. Ultimately, the important thing to acknowledge this unusual phenomenon came from Hubble Area Telescope observations, revealing that Betelgeuse's dimming became maximum, possibly resulting from a giant ejection of warm fabric into area. This cloth fashioned a dirt cloud that obscured a portion of the star's surface, effectively lowering the amount of mild reaching us from Betelgeuse. The dust cloud was notioned to originate from excellent hot plasma, which erupted from a massive convection cellular on the star's surface and then moved through its warm ecosystem to the chillier outer layers. As it cooled, it fashioned dirt grains, growing a cloud that obscured light from about a quarter of the superstar's surface. Hubble's ultraviolet mild spectroscopic observations beginning in January 2019 were vital in constructing the timeline leading as much as Betelgeuse's darkening. These observes captured symptoms of the de-heated material shifting via the star's atmosphere inside the months before the dimming in December 2019. Several space telescopes additionally referred to the celeb's diminishing brightness, particularly in its southern hemisphere. This fabric, initially brighter than the star's regular luminosity, subsequently formed a darkish cloud as it moved outward and cooled. The idea was that this outflowing fabric and resulting darkish cloud brought about the celeb's unexpected dimming. The size of this ejection became enormous, thrusting Betelgeuse into the astronomical spotlight. The star expelled and predicted for 100 billion instances the mass commonly released in a widespread coronal mass ejection. This ejected fabric, believed to weigh several times as much as our moon, became sizable, not simplest for Betelgeuse however, also for our knowledge of stellar mechanics. However, what does this kind of huge ejection of fabric mean for Betelgeuse and supernova theories in general? The implications for supernova theories are substantial as they expand the expertise of supernova precursors and provide precious perception into the dying stages of significant stars. This facts offered an important clue to the next system and to call for and the future of Betelgeuse. Astronomers have long debated whether Betelgeuse is approaching the end of its life and, if so, what form its demise might take. The recent dimming event, while dramatic, does not necessarily indicate an imminent supernova. Supernova explosions are rare events, occurring perhaps once every few centuries in our galaxy. Betelgeuse has shown variability in brightness over centuries, suggesting that while it is a candidate for a supernova in the future, the recent dimming event is likely part of its natural variability rather than a direct precursor to a supernova explosion. Understanding Betelgeuse's variability and the mechanisms behind it is crucial for unraveling the mysteries of stellar evolution and supernova precursors. One intriguing aspect of Betelgeuse's future is the possibility of it becoming a supernova. If Betelgeuse were to explode as a supernova, it would likely briefly outshine the moon in the night sky and be visible during the day. Such an event would provide astronomers with a unique opportunity to study the physics of supernovae up close and gain insights into the processes that drive these cataclysmic events. However, predicting exactly when a supernova might occur is challenging. Supernova explosions are triggered when massive stars reach the end of their lives and can no longer sustain nuclear fusion in their cores. This instability leads to a catastrophic collapse followed by a powerful explosion that ejects much of the star's material into space. In the case of Betelgeuse, its large size and advanced stage of evolution make it a prime candidate for a supernova in the relatively near astronomical future, which could mean anywhere from thousands to hundreds of thousands of years. Astronomers continue to monitor Betelgeuse closely using ground-based telescopes and space observatories to track its variability and better understand the processes occurring within the star. The recent dimming event provided valuable data that will contribute to ongoing studies of Betelgeuse and other massive stars. In conclusion, while the recent dimming of Betelgeuse sparked excitement and speculation among astronomers and the public alike, it is likely part of the star's natural variability rather than an immediate precursor to a supernova explosion. Betelgeuse remains an object of fascination and study, offering valuable insights into the life cycles of massive stars and the mechanisms that drive their evolution. As our understanding of stellar physics and observational techniques continues to advance, we can expect to uncover more about the mysteries of stars like Betelgeuse and their ultimate fates in the cosmos. Betelgeuse's story continues to unfold as astronomers gather more data and refine their understanding of this massive star. The recent dimming event, observed in late 2019 and early 2020, brought Betelgeuse into the spotlight and prompted intense scrutiny from researchers worldwide. This event, known as the Great Dimming, raised questions about the star's current state and its potential for a future supernova explosion. Following the Great Dimming, astronomers used various telescopes and observational techniques to study Betelgeuse in detail. They observed changes in its brightness, temperature, and spectral characteristics, aiming to decipher the underlying causes of the dimming event. One hypothesis suggested that a large cloud of dust and gas ejected from Betelgeuse's surface temporarily obscured its light, leading to the observed decrease in brightness. This interpretation was supported by spectroscopic studies that detected significant changes in Betelgeuse's atmosphere and outer layers. Moreover, the dimming event provided insights into Betelgeuse's complex internal dynamics. It highlighted the star's variability and the processes occurring within its massive structure. Betelgeuse is classified as a red supergiant, a stage in stellar evolution characterized by instability and significant mass loss. These stars are nearing the end of their lives, having exhausted their nuclear fuel and undergone multiple stages of fusion in their cores. For Betelgeuse, the dimming event was a reminder of its dynamic nature and the turbulent processes taking place within it. It also sparked discussions among astronomers about the star's future. While supernova explosions are rare and difficult to predict, Betelgeuse's size and evolutionary stage make it a candidate for such an event in the foreseeable astronomical future. However, predicting exactly when a supernova might occur remains challenging and uncertain. In the meantime, astronomers continue to monitor Betelgeuse closely. They use ground-based observatories and space telescopes to observe its variability, study its atmospheric changes, and track any further dimming or unusual behavior. These observations are crucial for advancing our understanding of stellar evolution, supernova precursors, and the life cycles of massive stars like Betelgeuse. The study of Betelgeuse also holds broader implications for astronomy and astrophysics. Supernovae are not only spectacular cosmic events but also key to the synthesis of heavy elements and the distribution of matter throughout the universe. Studying Betelgeuse and similar stars provides valuable insights into these fundamental processes and helps astronomers refine their models of stellar evolution and supernova mechanics. In conclusion, Betelgeuse continues to captivate astronomers and enthusiasts alike with its intriguing behavior and potential for a future supernova explosion. While the recent dimming event added to its mystique, ongoing observations and research will shed further light on the star's evolution and ultimate fate. As technology and observational techniques improve, we can expect new discoveries that deepen our understanding of Betelgeuse and its role in shaping the cosmos.